Hello everyone, welcome to the presentation. Thanks for coming and thanks for your attention. Yeah, today actually we are gonna talk about the kind of, we propose the kind of an application and we call it as a trash assistant. And with my colleague Krystian, and we are working for PwC and we are located in Gdansk. We are in actually financial crime unit, but it's, as you may understand, it's not related with financial crime or anti-money laundering, maybe anti something else. But actually, we kind of came up with this idea, and our, let's say, management team very supported this. We somehow wanted to promote it as a social responsibility project. So we are also planning to knock on the door of the Gdansk municipality because they seem they're interested in kind of application and make it like wider and so on. Of course, today we would like to mention you what we did, how we collected data, and what kind of approach did we use. And then there's gonna be small demo version, but don't expect so much, please, because this is very, very prototype, even like a very early alpha version of the app. So, but we are on the progress of improving it and then packing it and putting it into the store, Play Store and App Store soon. Well, this is our content for today. First of all, we would like to mention what is our motivation behind this. Of course, I shortly gave you kind of an information, but I would like to tell more. And then we use transfer learning for this task, which is quite popular nowadays, and it actually saves a lot of time and it helps data scientists. So we will talk about it a little bit. And then we had two approaches when it comes to classification task, because at the end, okay, we have image recognition task, but actually basically we are trying to classify those images, right? And then we will talk about the Kivy app. So have you ever tried to build any Kivy app? Kivy? Okay. How many people heard about the Kivy? Okay, cool. And actually this is very interesting framework. We're also going to talk about it. It allows you to build cross-platform applications using Python, but I would like to tell you that we are not an expert on Kivy app. We just discovered it and we just wanted to use Python to build such, application basically. It's very interesting, and because previously we were using Shiny and we were looking for Shiny application, we were looking for some alternative to this. Because we are data scientists, unfortunately not developers, so we don't have so much knowledge about the proper software development basically. So anyway, we decided to go with Kivy, and you will see what we actually try to do. Yeah, as you may know, in all over the Europe, this European Union was very strict about this trash segregation, and even they started to rank countries. So, and they set very hard rules, and they even was going to fine some countries because of not very well structured trash segregation system or system or approach. So in Gdansk, we live in Gdansk, as we mentioned, and the municipality is also very strict and they are very aggressive when it comes to trash segregation. So even one of the companies was fined, we know it, so we cannot tell the name of the company. But the fine wasn't, like a small amount. And also they are even giving rewards and, tax deduction based on their trash segregation performances to companies, to buildings and so on. So basically we decided to maybe provide an application, because sometimes it might be confusing. When you try to just throw your trash, you're going in front of the bins and you're looking at the trash, looking at the bins, and you're saying, okay, what now? So let's talk about the milk bags, right? So what do you think, where you should throw the milk bags? To paper? Okay. Cool, okay. So it was confusing for us, you know it, that's good. In Gdansk we are confused basically, but Warsaw, you know, is capital, so probably. You know, we are next to the sea, we are a bit relaxed. Okay, anyway, so yeah, it was a bit confusing for us. And then we just decided to have an app, have an application to provide a solution for this. Basically, the application, the main idea behind the application like this, okay, you will go in front of the trash bin with a lot of question marks on your mind, and then you will just take a photo of your trash, and it will tell you which is the class of this trash, and you would know which bin you should throw. And then we, of course, didn't have so much time to, you know, collect trashes, and also, you know, it's not a nice work to go and take a photo of trash and so on. And we found open source data set for this. And we used transfer learning. We decided to go with VGG16. And we basically customized this architecture, frozen some layers, and, you know, provided some customized layers. And the results were quite promising. And afterwards, we implemented this VGG16, customized VGG16 model to a kivy app. So then basically, it was very promising. As you can see in Gdansk, this is the mascot of the trash segregation. Even those instructions are in English. So even, you know, they think about the foreigners. This is very nice. So basically, there are actually, in some cities, it might differ, because in some cities, there are just only 4 classes, but in some cities, there are just 5. Like in Gdansk, for example, Gdynia is the next neighbor of Gdansk, but there are only 4. Never mind. We basically, with this idea, tried to build such a solution which may help to tell you which trash bin you should use to throw your trash, basically. And so I'm passing the stage to my colleague, and he's going to talk about basically the approach. And afterwards, I will come back and try to show you the demo, small demo.
Okay. So, as we said already, we use transfer learning for the classification task, and like for those who are not familiar, transfer learning basically is very similar to the human approach for learning things. So we use the data that we learned before for categorizing new tasks. So yeah, why we actually use the transfer learning? The answer is simple, like the calculation times. So using transfer learning, the model should predict like earlier the better results. So as you can see the curve, we should have higher start of accuracy when it comes to classification, higher slope and higher asymptotes. Also, the probability of overfitting the model might be lower using the transfer learning. Yeah, but be sure that you're using the model that is related to our tasks. So, like, our problems should be basically similar.
So, for example, let's maybe give a bit detail here. There are a lot of state-of-art architectures, like, you know, it's the AlexNet made the first huge impact in the ImageNet competition. So then, you know, there was another cool state-of-the-art architecture. VGG16 came, and Inception, a ResNet, and different one. So all of them they are, you know, trained on different type of data set, and some of them are trained on, you know, cats and dogs photos. Some of them are based on like very wide of different image classes. So basically, this is very important. You should know that how this state of the architecture was trained and was built. So you shouldn't use a state of architecture which is not related to your task, basically. So yeah.
But for classification of pictures, it's very convenient to use such architectures. So a couple of words about the data set. We used 2 different data sets that are available on Kaggle. So waste pictures and trash detection. We went through this, all of those data sets manually and selected the pictures that, well, the quality of the pictures was pretty nice, say. So basically, we ended up with 4,000 of pictures. We divided it also manually to train and test set. Yeah, and two different approaches to classification problem. So the first approach was to classify, like to set the labels as we have in our trash bins, in Gdynia trash bins, to be specific. So glass, paper, plastic and metal, and the other non-segregable trash. But we are aware that for some classes, like especially plastic, we have a couple of different objects that we can put there. So for example, the milk box, the plastic bottle and plastic bag, let's say. The structure of those objects is very different, so the model might get confused when it comes to classifying all of those three different objects to one class. That's why we also wanted to try the model with 8 different labels. So then we could merge those labels into like one final plastic one. Yeah, we should remember that there is always trade-off. So with 4 labels, we have well, less labels. So the model will have like a smaller chance to make bad predictions. So the accuracy should be higher. But on the other hand, using 8 labels, the model performance might be better because the model will understand the structure of each object in a better way. Yeah, so those are the examples of pictures that we used. You can see there are different of those. Yeah, with uploading the data set to models, we used image data generator from Keras. With rescaling, shear range, zoom range, and horizontal flip to avoid too much overfit of the model. Okay, and the training part. Basically, all of the training was conducted in Google Colab. We used Google Colab because they are providing the free TPU. And it helped to develop model because when we tried the same architecture on CPU, the approximation time of one epoch was around 2 hours. When we tried with GPU, it was around 40 minutes, something like that. With TPU, we managed to shorten the time up to like 52 seconds per epoch. So this is great. But be aware that using TPU might be confusing because when we tried the same code the other day, the time per one epoch was around 5 minutes. So somehow it's not like 100% reliable. We are not sure why, but yeah, this.
Yeah, what we actually came up with related to this topic, because this is free platform and probably they're not putting a lot of effort to manage this resource. When there is a like huge load training the model, and we were also checking the time. For example, around 5:30 p.m. the TPU was getting confused and the process was getting slower because in United States it was morning. So probably like there is a kind of problem with resource management, but still the good resource because we didn't have to, have AWS or any other Google Computing Engine platform. Basically it was free.
Yeah. Yeah, and for architecture, as we said, we used VG16 with a couple of our additional layers, so 2 real evidences, 1 softmax, and 2 dropouts. We use also early stopping in learning phase with like rollback to the best performing one. Yeah, and we compile it with Adam optimizer and categorical cross-entropy loss. So this is how the architecture of VG16 looks like. We didn't try the VG16 like itself as whole. We tried to froze a couple of layers of these models. So we tried with freezing last 4, last 8, and last 12 layers of the model. So therefore, like those layers were not used in the classification, in modeling part, basically. Yeah, and we use TensorFlow library for additional layers, for compiling. We also, in VGG16, we used initial weights from the ImageNet dataset.
Maybe small note here, as you might know that with TensorFlow 2.0, you can also call Keras functions within TensorFlow, and it's a bit faster and it's a bit, you know, providing better performance. That's why we decided to go with TensorFlow, and for some, you know, tasks we just called Keras functions from TensorFlow, and it was actually pretty good.
So this is how you basically create the model. It's very simple. It's a couple of lines of codes. So we can collect the VGG16 like straight from TensorFlow models. And then for frozen the layers, it's one very simple loop. So we can just set the layer trainable to false, and that's it. Yeah, we added the additional denses and compile it, and that's it. So let's check the results of the models. So as we said, we tried two different approaches. So here you can see models that were trained based on 4 classes. So couple of similarities. For initial stages, the test validation was accuracy was much higher than the train one, for some reason. At like 10 or 15 iteration, it started to slow down, and then we can see like the small gap between train and test accuracy. We managed to reach the 0.86, 0.85 accuracy for most of the models. For 8 classes, like the initial stages went pretty similar, so the validation accuracy was higher initially, but then we cannot see actually this gap between the train and test at the latest stages of the model. But yeah, again, the accuracy is lower, as we mentioned, and this is totally understandable because we have basically more classes. Yeah, so we can see how those labels were actually predicted. So both models performed the best for trash, so non-segregable wastes, and both of them were a bit confused when it comes to the glass and plastic and metal. Probably because of the structure of the bottles, like plastic bottle and glass bottle is pretty much the same.
So right now we will try to show you the demo. So basically just quick introduction about kivy app. Kivy app is an open source Python library, and for very quick development of applications, and you can basically develop cross-platform applications. You know, it can be desktop application, can be Android or Python. Sorry, iPhone. iOS application. Sorry for that. So iOS application. So it's you can also go to visit this website, and you will find very useful information here. And it's this framework. Okay, probably you cannot see on the screen right now. But okay, so. All right. And this framework is also used for game developments, and some gamers, game developers are using it for this. And there are also some examples about, I think one of the PyData conferences application was developed with this kivy app, kivy framework. So you can see it's very straightforward and very easy to develop such, very simple applications. As you can see here, just with a couple of lines, you can have a very simple app. And ours also looks pretty similar to this one. I mean, it doesn't say hello world, of course, but it's not so complicated application basically. I will also try to show you how the code structure looks like. So basically, okay. basically you have one main Py file. Okay, it's very hard to control. Anyway, so you have one main Py file. So basically here you are giving the instructions to the computer or to the app. Basically you are saying that, okay, put here the button, and on this part it's happening. Put a button there, and then take a photo, capture a photo, save it to some location, and then afterwards you can clearly call the Python script where you have this model prediction part. It's also a very straightforward one. We are basically calling the model, and here, as you can see, okay. Yeah, I'm trying. Okay. So basically, here you can see we are loading the model. This is stored in the H5 format. So we are loading the model and then passing the image here. So using this image, we are generating the predictions, and those predictions are provided as classes like 0, 1, 2, 3, and then we are mapping them here, basically where we are having the results. So let's try to do like a quick demo. So maybe I can show you a couple of things which we actually did today here. We were sitting on the rear side, and we just was testing the application. So on the left hand side or right, I cannot say. it's right for you. So you can see that this is the batch, and the model predicts it as a plastic, and we also put 2 glasses there, and it also managed to predict the glasses perfectly. But we have sort of a problem when it comes to glass and plastic, because those images are pretty similar to each other. So imagine that plastic bottle is also transparent, and the glass is also transparent. So for example, yesterday we were also testing the model and application. So when there was a reflection on the plastic bottle, it detected it as a glass, which sort of makes sense. We are trying to add additional features to deal with this. For example, we are thinking about adding reflection, like collecting this information from the image when we are processing the image and passing it to the model. Maybe it might help, because it's mainly based on the colors and those features, because this VGG structure is extracting those features. So basically, we are also trying to do some ensemble learning, perhaps maybe passing this features to different model and feeding the new features with the second model, and then merging them, kind of having a hybrid structure. But yeah, there is a couple of things to do here. So here also on this chart, you can clearly see this the problem. As you can see, we actually mainly have plastic images. So on the reality, they like 28 of them aren't actually really plastic, they are glass. So it confuses the plastic with glass because of the things what I mentioned. Also, there are also bottles, right? So think about those energy drink bottles, right? They are colorful, but think about also wine bottle. They are also, black or in different colors. So it a bit is getting confused. All right, so let's try to run this app. Okay, I will try to make it a bit bigger. Okay. So basically, of course, for now we are running this application from the command prompt, but it's easy to just run the main Py file. So it pops up me, it pops up a kind of a window where you can take a photo. So for example, we can take a photo of the badge. Can you, please? But without you. Mm-hmm. Okay, we lost the application. It happens. Okay. Ta-dam! Plastic. Yeah, all the effort was just for this. So, but yeah, of course, this is, like I said, it's very early alpha version of this application. But we experienced many different things, and it was actually good experiment for us. And like you also mentioned, I think Rafa was mentioning that it's very hard task. So we actually saw some points should be improved, and we will be working on this. And also we're planning to, like I said, knock on the door of the municipality and ask for some funding, companies supporting us, and basically converting it to a bigger project, because it might help, to have better segregation, trash segregation, basically. And it's also a good experience for us, like we might have a good application perhaps if everything will be all right. But the first results are promising. So yeah, I think we are pretty much on the time, on time. So thanks for your attention.
One, two questions? Nope. Okay. Have you already spoken to the municipality?
Not yet.
Okay.
Yeah, this is the plan.
All right.
Because, like I said, they are very aggressive. They are very aggressive. So, and also what we heard that in Gdańsk there's a very good trash segregation system, and the frame, the place where they can segregate the trash, and they are actually doing good job, but they would like to have it much better and with less effort, basically, and that's why they are asking people to contribute. So we are thinking that their response will be positive, and then maybe we can have like a bigger project.
Would be good to have it in a trash bins actually. So implement in a hardware.
We also have some ideas like this. So putting some iBeacons to the trash bins, and it would understand you're around this trash bin. And we are also thinking about some loyalty points. So let's say, for example, if you collect 100 points, you would get free transportation ticket, or like lunch in some good place, things like that. But of course, it needs money and it needs resources. We have everything in our mind and written somewhere. We will just, put everything together and just go and tell them, guys, give us money, basically.
Okay, thank you so much. Thank you so much.